DefCon convention. This meeting was held in exciting Las Vegas, Nevada from July 9th through the 11th, 1999. This is videotape number 19, Insecurities in Networking Devices.
Well, I'll make them available on the DefCon site afterwards, and then you'll have them there. My name's Rooster, and I am a network engineer. I design and implement large-scale networks, routers, switches, ATM, FIDI, whatever you want to call it. Deal with all different aspects of networking issues. So what we're talking about here today is insecurities in networking devices. But the question is, how did we come across the problem? The problem is, back in the old days, like way back in the Stone Age, when they were chopping wheels out of rock, they used to manage things through the console port, which was really cool when you only had like 3 routers to play with. No big deal. But then as time progressed and man became more advanced, they discovered other countries, and they discovered need for offices in other countries. So they had to decide how they were going to actually manage these routers in other countries. So say you set up an office with like 5 people. You put your network connectivity there, but you don't have enough people there to make it worth getting a network administrator for every site. How do you take care of it? Hence the need for remote administration. The problem with remote administration, remote management, is that anytime you leave a path for yourself to get into a device, you basically leave a path for somebody else as well. And the less you know about that path that you've opened, the more the other person is going to know how to get into it. One of the biggest problems with remote management is the lack of understanding by the administrator what he's got. In fact, most networking devices actually come regularly set up with remote management turned on. You plug it in, you turn it on, it's there. People don't even realize this. In fact, with really basic configurations. Since there's no authentication for a lot of these, it's pretty easy to get through. So the things that we're talking about today, we're talking about routers, we're talking about Ethernet switches, we're talking about ATM switches, FIDI, basic network infrastructure, the stuff that you start with when you design your infrastructure. So just to make sure everybody's, we're all on one page, we'll talk a little bit about what the difference between a router and a switch is. So when we're talking about the different devices, we all know what we're talking about. The problem with router and switch is marketing has come through and they've totally redefined the way that people use these terms. They've got, layer 3 switches and layer 4 switches and just a bunch of marketing mumbo jumbo. It means nothing. I mean, if you really want to come down to it, most likely you're talking about, if you're talking layer 3, you're talking a router, and if you're talking layer 2, you're talking a switch. Layer 3, as a general rule, your router is what's going to go between 2 different networks. Layer 2, you're going to segment the same network. Hope that makes sense, y'all. Y'all look kind of bright, so I figured it's probably a waste of time telling you this stuff. All right. The methods that people use to manage these tools, the management for networking devices, the basic protocol for this is called SNMP. I'm sure everybody's heard this. By the way, if anybody has any questions, like if I go too fast by something, please feel free to stop me, and then we'll have questions at the end. So SNMP stands for Simple Network Management Protocol. This provides that management capability remotely. It's actually an amazing protocol. It's really, really simple, and it can do a lot of amazing things. The problem is that it does a lot of amazing things very insecurely. As many people know. You can do just about anything depending on the manufacturer of the device with it. For instance, Cisco has got kind of a half-assed implementation of SNMP, so you can only do so much. I mean, you could do anything, but unlike, let's say, something like Bay, where it's just like everything is completely open to SNMP. It's UDP, so anything that's UDP based is going to be insecure. UDP is as you know, is they said, well, let's make the most basic protocol that we can, and we'll let the application worry about things like security and checksums and, fragmentation and things like that. So UDP does nothing of that. It goes across, everything on the SNMP goes across in clear text. There's no encryption, nothing. No authentication, there's nothing involved at all. So you put a sniffer on the wire, you're seeing exactly how the management system's working. And as such, it's completely insecure. It's probably one of the weakest protocols that we have on the internet, that as important as it is, has become. The way SNMP works, it has a really, really basic, kind of primitive method of authentication, passwords. But they're not really called passwords, they're called community strings. And what community strings are is basically a password that each device allows access to a different part of it. Community strings usually come in two variances. There's actually three, but the two important ones are read-only and read-write. Read-only allows you access to, basically, you can look at anything that's on the router. It says read-only. Read-write actually allows you to make changes on the switch or the router. Well, I want to briefly address SNMP on your hosts, Unix boxes, things like that. There's actually not a lot you can do. The manufacturers of HP and all these people haven't really put a lot of functionality for SNMP in their hosts. There are a few exceptions, and it's good to know that there are definitely some bugs with SNMP in hosts. I mean, the obvious ones are going to be buffer overflows for root. I mean, I saw 5 of them just the other day. In fact, there was one that Sun had that a good friend of mine, Alhambra, came up with, where Sun had a SNMP community string hard-coded into their SNMP daemon, so that it didn't matter what you set it at, this one would always work. Nice little backdoor that they provided for everybody. Something to always watch out for. Actually, as a side note, backdoors are something always to watch out for. Does anybody here use 3Com? Nobody uses 3Com routers? You realize that with a 3Com router or hub, that if you have a MAC address and you're on another 3Com hub, you can automatically gain full access to any other 3Com hub on the network. So if I come into your network and I plug it in and I have your community string and I have your MAC address, I just remote into your router, just like that. It's very simple. In fact, this was 3Com's wonderful management system versus Telnet. Okay, another method that they use for managing is called TFTP, Trivial File Transfer Protocol. Once again, this is UDP, and it has no authentication. It doesn't even have passwords. If you're lucky, you have to use community strings. TFTP was originally designed to make it so that machines that were booting up on a network would be able to get their configuration off of a server. So they wouldn't have any way of authenticating because they wouldn't even be fully booted up yet. So now, network vendors will use this protocol to actually move configs on and off of a router. The main part of, the part that's important of SNMP is what's called MIBs. MIBs stand for Management Information Base. MIBs are the actual data that are on each networking device that provide the information that you can query. The amount what they have MIBs is dependent on the manufacturer, and it varies everywhere from, most manufacturers now have just about everything you could possibly think of in the MIB, from the temperature of the box to how many interfaces are on to the serial number that the box is. I mean, everything. You find out the IP addresses, the switch. If you're on a switch, you can see how many ports there are. You can even find out the text that's of the port, how you've got it defined. So like an ATM switch, you'll have a text with each port that defines, where this particular OC3 is going. With that, when they came up with SNMP, they developed this thing called Enterprise MIBs. And what an Enterprise MIB is a way for the huge standard for people to for MIBs. So basically, in a way, you could consider it like DNS in a way. You start at the very root, which is 1, and it actually is a string of 8 numbers, depending on the manufacturer, but the first 6 numbers have to do with starting with the root, going through the fact that it's DoD, internet, it's a private network. All those are always the same in every MIB, and then every organization is provided with a number, and this number signifies that organization. So Cisco's number is 9. So I have to read this to you because you can't see it. But the actual beginning of a MIB number for Cisco is 1.3.6.1.4.1, which basically means iso.org.dod.internet.private.enterprise.9, which signifies Cisco. This will allow basic, standard structure to the whole system. And when I provide the slides, I actually have some FTP sites that provide the entire list of everybody's organization. Now, the standard ends there, because on one side, if I have say the number for how many interfaces exist on the router is 41, that's not true across manufacturers. But all manufacturers provide documentation on their MIBs. In fact, if you want Cisco's, you go to ftp.cisco.com. They've got this huge directory with every MIB that they have. Now the question is, at this point, what do you do with SNMP? I mean, how can you use this to do any kind of exploit? So there's tools that are actually provided for you on most Unix boxes. They're called SNMP Get, SNMP Set, SNMP Walk. So with SNMP Walk, what SNMP Walk does is you put in SNMP Walk, you put in the community string, and all it does is it goes and it walks the entire MIB tree. Now, this may not seem like such a big deal, but this will completely take out any router you find on the internet. It will DOS it, no doubt. It actually tries to walk the entire ARP table and routing table. So if this is a router that takes BGP routes, for instance, it's going to try to walk all 60,000 routes, including, like I said, its ARP table, so all its internal network as well, which is more than any router can handle. And so it will actually just take it out. The other ones are actually a little more insidious. SNMP Get and SNMP Set. These are the tools that you can use to access the MIBs that are available on these particular routers. All right, well, I have this list of really cool MIBs. Trust me on this one. And what these particular MIBs are, if you can see them, are on a Cisco, because I just pulled Cisco out randomly, no real reason. There are 2 particular MIBs that are your best friend. They go through the whole standard part, and host config set and write net. What host config set does is you pass it a particular configuration, and it will change that configuration on the router, whatever line you want to. What's even better is WriteNet, which basically tells it to pull from your TFTP server a config. So you put yourself a nice little config out on a TFTP server, send that to a router, it will go to that Unix box and pull the config off. Okay, so let's say you get inside of a router. The question is, most people don't seem to understand what advantages they have by gaining access to the infrastructure. One of the big things you can do inside of infrastructure is you can map the entire network. Those routers have ARP tables, they have routing tables, they know where everything is. If you're in a Cisco environment, it's got what's called Cisco Discovery Protocol, which turned on provides every router, every information that's right next to that router. Then, for instance, one of the benefits of this is most people don't actually have switches that you cannot see the switch. So say you want to get access to a switch to find out what servers are on that. Well, when you trace route through a box, you can't actually see the switch because obviously it's layer 2 and it just passes over the top of it. When you have access and you do show CDP on that, you will see the switches as well as the routers. So getting access to the switch at that point is a cakewalk because most people don't put passwords on their switches. It's simply amazing. But they do put up IP addresses, so that's really nice of them to do that. One of the beautiful things about getting control of the network infrastructure is that the inside of somebody's network is always the soft underbelly. Nobody ever does anything internally. Say, oh, I got my routers in front of me, I got, maybe some firewalls. Nobody can touch me inside. So there's not much point in putting things like, oh, tough passwords that I'm going to change all the time, any kind of real authentication or anything. I mean, who's going to be able to get access to that? So, you're in. Probably, it's the same kind of thing about when people have an inside job, which they don't really pay much attention to, but you can make changes to routing at this point. You can make changes in layer 2. One of the big things you could do, if you were so inclined, is layer 2, like say ATM, and you've got a site, you've got another site that you're attacking. You can very easily, when you have control, redirect all their traffic to you at a layer 2 level, which means that you don't even need IP connectivity anymore. You're just pumping data at yourself that you can capture out of the ATM unit. There are things that are coming out, or that have been design spec'd to try to alleviate this. SNMP version 2 has spec. It's never used, and it probably never will be. I would be very surprised if it's ever used. It provides authentication. It's more streamlined. It's much more secure, but it has a lot more. It's a little bit tougher to implement, and it's really expensive. Anytime when you have to change a big standard like that, it's really expensive. And most people don't seem to realize the importance of things like security. Go figure. So I wouldn't bank on that being really used very much. Oops. No, I screwed myself up. Okay, so now you're the network, and you really don't want people accessing your router. What can you do to protect yourself? One of the most important things to protect yourself, well, there's several. First of all, don't use private and public as your community strings. This is like the biggest mistake that, people laugh, and it's funny, but I cannot tell you how many routers I find out there with these as their community strings. They turn on the routers, they don't even think about the fact that SNMP is set up, and they just walk away from it. And that is what all manufacturers put standard as their community strings. So you can pretty much just walk through the internet and find dozens upon dozens of people who have not changed their configuration. Of course, you could probably find dozens where the password is Cisco, but access lists. Now, this is going to leave out mostly the ankle biters, especially with UDP. Access lists are not exactly the toughest thing to bypass, but you might as well use them because they're there and provided. Cisco, for instance, provides two different kinds of access lists. They provide what the standard access list, where you can actually block who is allowed to do SNMP queries, SNMP puts, and who is allowed to do TFTP services. And you can also who can do telnet and things like NR login and things like that. Might as well put them up. It's got the extended access list on it, so that you can filter even more tightly than that. What else did I say? Sorry, it's a slow computer.
How much more granularity do the extended access list give you?
Extended access lists give you the granularity of using port, the status of the packet, meaning SYN or ACK, and by host or by range of hosts. So, for instance, standard access lists do not give you the option of doing by by network. It can only do by host. But the extended one gives you the access to the host, to the network. All right, I think there was just... proper logging. Proper logging is really, really important. You need to know who's doing changes on your routers and who's not. And we're talking off-host logging as well, not leaving the logging on your host and reading it from your host and hoping that you catch the person as they're doing it. Syslogs provide a tremendous amount of information, and they will tell you exactly if people are making configurations to your boxes, your routers, and they will tell you what configuration changes they're making. Having nice tools that go through your syslogs and pull out any possible security violations is a huge help, because 99% of the people out there the people trying to get in don't really understand syslogs. So what was it? So your access lists, and that's pretty much it for securing. So that pretty much covers it. My quickened version of this to make sure we can get the experts done. Is there any questions? Sure.
Do you have any feedback on like the ISL protocols or anything like that?
The ISO? ISL? Oh, the Cisco bridging stuff?
The switch VLAN bridging over one port, yeah.
Well, it's actually not quite the focus of this, but I know what you're talking about. And whenever you're talking VLANs, you have insecurity problems. And when you trying to map VLANs to different ports like that and adding extra protocols, you're adding insecurities. I don't know of anything in particular with ISL, but I wouldn't be surprised if something exists. Especially because there's no authentication of ports, right? So if I'm on a host and I send the correct command to the port, a lot of switches will actually let me change VLANs, which is, another really bad thing. Especially if people are using VLANs to, try to segment their network in such a way. Actually, I almost forgot. That's what I forgot. Segment your network. One of the big problems with this is that it's clear text. So you can put access lists into Sun and Shine. You can put the most incredibly strong community string that exists. But if anybody perchance owns any box on your DMZ, and I'm sure most people have a machine or two that sits outside of their firewall and outside of their normal infrastructure, probably on parallel with the routers. They own one of those boxes, they set up a sniffer, they're going to have it. So it's good to segment out your network. Throw away the hubs and put switches in, because it's the best thing, one of the best things there is for security on that, keep people from sniffing. I'm sorry, go ahead.
Actually, switches wouldn't provide much protection against sniffing, because all you have to do is generate the MAC addresses of the machines that you want to sniff, and then think that that's legitimate.
There's ways around it, sure, but as a general rule, you have to know enough about the switch to be able to pull that off, and you have to know what kind of switch they're running to pull that off, because I don't even think that'll work on a Cisco. You know what? I've never tried it. I know it works on 3Com, but yeah, there are ways around it, but it's definitely better than putting a hub up.
He's looking at the send ISDN routers. This is really complicated.
Say it again?
Maybe that send ISDN routers.
Send ISDN routers? ASIN? Oh, Ascend. I'm sorry. Ascend. Okay. So, you want to know about those?
There's a lot of small and mid-sized businesses use this.
Ascend actually has quite a bit of security problems. A lot has to do with SNMP, because they actually allow a lot of functionality with their SNMP MIBs. And beyond that, I know there's problems in the dial-up part of it, but do you want to say something about it?
I can't, because I don't want to lose my job there.
Oh. Yeah, I know they have problems. All right.
There was no protection against anybody telling them directly into it.
Yeah, they don't have access lists that way, like a Cisco router does, and they're really
They don't have a password set up in the default.
Right. Well, which is why most people don't really have that remote a configuration in their sense.
I have a comment. I think I understand the importance of being able to SNMP walk boxes, because it gives you version information, it gives you uptimes, memory usage, there's looks like a gold mine.
Oh, absolutely, but usually when you do it, you're not going to get any information because you're going to take the router down. I learned this the hard way, actually, legitimately, taking my border routers down by SMP locking them.
You don't have to SMP lock the entire tree.
Well, right, you're right, that's very true, you don't, but that's, but if, yeah.
Getting the good information on the top of the
Right. Oh, that's very valuable information for getting more access to the router. You learn what version of code that they're running and, do a search at root shell, what bugs in that one. Go ahead. Yeah.
Oh, okay. It's kind of a basic question. In order to keep log on a router, IP addresses and stuff like that, you don't go to communication, say it's not public or private. Is there a way to find out the community string?
Sniffing, yep. If it's on a shared network, you'll be able to find it that way. Because basically, what's happening is you can be on a shared network where people are passing the data back and forth over the router, which does happen because I've seen people administer routers over the internet, and it does exist.
You mentioned backdoor passwords, particularly your backdoor passwords for Microsoft Engagement by Windows 95 as well as
was there? I don't know about those, since I don't really deal with hosts all that much. But
also, you mentioned email. Long iterations.
Yep. Yep. Yes, and SMP3 is like in the stage of being an IETF standard and not, or it's in draft stage if I remember correctly. Has it?
It was announced in December last year. So there are several implications, but the thing is that it's very complex.
Yes.
And talk about URS, I think we have to do that.
Yeah. You got a question? Yeah.
Yeah, what about running CBAC?
Running what?
CBAC? Cisco routers will actually perform some applications, like the firewall feature set.
To be honest, I don't really use those app parts of Cisco because I don't really trust them. I use their access lists. I don't use their firewalls. CBAC, which you're talking about, I don't really get involved. Small services, shut them off. Pretty much back down to what a Cisco router is supposed to be doing, which is routing traffic.
Services that allow to do that. You're likely to have to act as application gateway.
So it's an application proxy. I don't really use it because I use other application proxies, so I've never really played with it.
You mentioned syslogging everything and using the right tools, but you have a recommendation on
well, you're going to love this, Perl. I have to say, I'm a little bit jaded because one of the people I work with is just a scripting god. I've never seen anybody who can do the things he can do with a script. So I've seen pretty much in whole infrastructures based on scripts that'll go through and all the configurations, match it against TACX logs, compared who's actually logging into routers and who's making changes, all possible through standard Perl tools.
and it's not
if you go to the Perl sites, they have tons and tons of scripts available. And to be honest, I'm not sure what commercial tools are available to do that kind of thing.
On Cisco switches, we're wondering about the span ports. You go across there, how many vulnerabilities with those, especially when you use that like an IDS system, go over multiple VLANs?
No, I actually haven't found any. I really looked at, I've done spanning before, but I've actually never said, I wonder how I could break this thing. Other than the fact that just by having that available, if somebody gains access to the switch, they can then span the entire switch. Which, once again, I want to point out, it seems like, of course you're getting access. Getting access of a Cisco switch is trivial because nobody ever puts passwords on these things.
Seems to provide an access control list. Can be bypassed actually want to talk about that?
Well, sure. Spoofing can do it, especially when you're talking about something like UDP, right? I mean, you're sending UDP packets out. You're not expecting an answer back. So I wouldn't say it's trivial to construct a script that would basically build UDP packets on the fly that would make configuration changes with spoofed IP addresses. One thing you can do, one thing it's really important to do in a Cisco router is basically put up an anti-spoofing type access list. All it does is says, on the outside interface, I don't accept addresses coming from the inside. Very important.
One thing I want to mention about scanning for Cisco switches is that currently you can only scan the ports that are on your box. If you have a network of switches for several of them are chunked together, you can't see the traffic that's on them.
Right.
And that's supposed to be a feature of remote scanning that's going to be in 4.5.
Oh, that's beautiful.
On-device logging via syslog there was a use in a previous version of iOS. An iOS service attack could be launched if somebody was logging everything that an access list denied, and the router was then all of its sites sending those logs to the log host rather than doing
Which kind of points to the importance of making sure that you have the latest and greatest code. And I don't mean the latest like 12. I mean the latest code with the bug fixes and the security fixes in them I mean, there's a ton of stuff that's been fixed, but I've seen people run 10.9 Cisco out there, and, everybody knows the problems with those.
Even within certain trees.
Right, exactly.
You have a CCO login, read the release.
Hence the problem with Cisco source.
You mentioned that big network routers are heavily SMB managed, which is very true. So there are a lot of additional weaknesses inherent in the
Actually, no, not really, because with any of them, you can change the configuration. It's not so much as weaknesses as just it makes actually manageability a little bit easier. But any of them you can use to break in that.
If you're using Cisco for an ACL to block a majority of the Insecurities or whatever, then I would suggest putting an outbound filter on the external interface so that it actually doesn't even respond to packets are dropped from the administrative role list.
Oh.
Sends it off to null.
Yeah, or don't send TCP refuse, or what is it? Will refuse and don't send any packets back. What you can do with the Cisco, it'll just let it die. Well, the benefit of TACAX and Radius is login authentication. TACAX provides a one-time power, theoretically a one-time password, and it doesn't really work that effectively, but it provides a way for you to have an authentication for when you do logins. It won't do anything for SNMP at all, but it'll stop login type attempts. Radius allows you to have a central database of users and their authentication. Oh, well, no comment.
May God have mercy on you.
Yeah, UNNT is an operating system for your router. Well, the problem is that it's funny because there's this one router that I saw out there that's like probably the fastest router that exists, and it runs NT as its operating system. It's kind of a toned down version of it. It's more of an embedded version of it. It's almost an NTCE, but and it's like, all right. But it's the fastest router that I've seen existing, and Berkeley Networks, I believe, is the router name. Yeah, it's fast because of the hardware, not the operating system. We should make that clear. So there's many problems in that when you're dealing. The benefit of using something like the Cisco and the Bay is they don't really have a real operating system. They're just this loader with some protocols. Okay, one last question.
Hold on,
Oh, okay.
Real quick, folks, if anyone knows a Brett Bressler or a Roman Israel, they need to go immediately to the second floor and talk to a lady by the name of Sharon. There is a urgent family emergency. Mr. Israel is wearing a Amish hat. So if you spot him, please kick him into play and making sure he goes upstairs. Thank you. Oh, and by the way, there's a gentleman in the back wearing a yellow hard hat. This gentleman is from Linux World. Is that correct? And would love to talk to anyone who loves Linux. Or not.
What's Linux?
And sir, running NT on a router, may God have mercy on your soul.
Okay, one last quick question.
Just wondering if you had any comments on Armon vulnerabilities?
I don't really know a lot about Armon. That's kind of new for me. I would love to tell you more, but I can't. All right, well, thank you very much for coming. Oh, my email address is rooster@resentment.org, if anybody has any questions. I liked it. Spot the Fed. Woo! What's that? Yeah, ftp.cisco.com. All right, thank you very much.